Hello and welcome to SudoKanard. We're here to solve this irregular builder Sudoku by Chen from Sudoku Grand Prix. Initially, I had intended to skip solving this puzzle on video, but there were too many requests to just not do it. So I tried to do my best because it's quite a difficult puzzle. 106 points, but might have been worth more than that, I think. So the special rule here is that this is a standard irregular Sudoku, except that the regions are not fully drawn. We have some walls, but we don't have all edges between the regions. So we know that the region with the 6 is different from that with the 4. But this is basically all we have to work with, and the setting is quite impressive with only odd digits here and even digits there. And actually the building part is really not that hard. The hardest part is really the regular Sudoku part. So I hope I managed to solve this part in reasonable time. So now where do we start? Well, this 4 surrounded by 2 8s is the way to go. We know that 4 must go only with one of the 8s, and if we try to pair this 4 with this 8, it means that we have a wall there, and we must go this way. 6 is not in the same region, so we need to go there, and we repeat the 4, so that doesn't work. Which means that 4 doesn't go with this 8, it goes with this 8 here. And we can take at most one cell here, so we must go this way. 6 is not in the same region because of this wall. So 6 extends this way, and our first region extends this way and must extend further. It must dodge the 4 and go this way, so that the region with the 6 now goes this way. This cell is in another region, this 6 is in another region from this 6. So we take the 8, this region here extends further. So we have 1, 2, and by the way, this 4 extends like this, it's another region. We have 1, 2, 3, 4, 5, 6, 7, possibly 8. So we must take this cell, we go like this, this 6 is in another region, we must go this way. So this region may be finished if it takes this cell. Note that this 8 goes this way. We don't know whether it takes this 4 or not, so same with this 6. So nothing more can be done here. This extends like this. And let's ponder the fact that those 4 cells are necessarily in the same region. If we try to put a wall here, then this extends like this, and this is isolated. Same if we try this. So all of this is together. It's another region than this, so there's a wall here and it extends like this. It doesn't go this way. So there's a wall here, and this is another region. This 4 extends, so now this region here must be closed here and take a 9th cell here. So this region is complete, and we'll remove those lines. This has 5 cells, it must extend, same like this. We have 5 cells here, 6 cells here, so they can't join, so more separations. This goes to the 3, this goes like this. We have 7 cells, so this extends, and they are still separated, so this extends even more. It extends even more like this. Those 7s do not join, so this extends, and we have 9 cells here, and here we will have 9 cells like this. So those regions are drawn. Here we have 7 cells. Will we take the 1? I think not, because this has to take the 1. We have only 7 cells. We can't go down because there's a wall here. This goes down, so we must take the 1. This must extend further and take a 9th cell. Here we have 9 cells. This extends. Here we have 4 cells together, like in this area. I will remove those lines. Now is a good time to think of what goes on here. If we assume that 5 doesn't go with the 1, that's the trickiest part, I think, in the building process. If we assume that 5 does not go with the 1, then it must leave this area like this, and 1 will leave separately like this, so that this 5 will have to dodge like this and join this 3, which is forbidden by this edge. So 5 is in the same region as 1, and obviously those must come together, because otherwise if we try to join the 1 this way, we will isolate those cells. So 5 takes at least this. We don't take that, so we have at most those 6 cells, this one, 7, 8, so we can't go that low. So we have at most 8 cells here, so we must take this one, and this region down there goes like this. We don't take this because there's a wall there. And if we assume that some cells here are not with the 5 and the 1, then they must leave here, and they are blocked by the region that stems from the 3. So that doesn't work. Those are necessarily with the 5 and the 1. And we have a total of 9 cells here. This extends like this. This region here won't go this way. If we try to have it join this part, then those cells here are isolated. So it will remain in this bottom part, and this bottom part contains exactly 9 cells. So this is another region. And how do we complete this? We need another 4 cells. And that is a very, very tricky part. I think I remember that this has to do with those digits here. Do we join like this, or do we join like this? That's the question. And it has to do with digits 1 and 5. Digits 1 and 5 are not in here. 1 is not in here. So this region to have... Oh, well, wait. I just don't remember what was my line of reasoning. Perhaps it's about 4 and 8. No, I remember it's about 1 and 5. We must take a 1 and a 5. What was my line of reasoning? What if it takes this? I was thinking there has to be a 1 and a 5 here. I don't see any issue. Well, I remember that the solution has the regions like this. I just don't remember what the argument was. I think it was about 1 and 5, and that this oh, I think I will need to pause and think of it. I found the argument. So if I assume that this joins the 3, it completes the region there, and now let's ponder those 4 cells. They don't contain 4, 8, they don't contain 1 and 5. So we must have 1, 4, 5, 8 in here. And I was thinking it wouldn't work. But it seems to work. So that's not the argument. And that's a very Bobbins moment. Well, perhaps it's not possible to find out at this point. And we need to do some Sudoku. And some Sudoku is possible because 5 and 1 are not here. So on this region, they must be here. So now we can see that 8 and 4 are not here. And they must appear twice in those cells. They will appear once in those cells, so that their second occurrence is in here. Those are 4 and 8. And they are a 4-8 pair. That's interesting. Those are even digits. So we can pencil mark something like this. Well, 4 candidates. I usually don't do 4 candidates, but this puzzle is very special, so I will do that. Here we have all odd digits. And something of interest is that those 2 digits are not here. Oh, simply 4 is not here, so on this row it must be there. So that's an 8. And this 5 is nowhere here, so inside this region the 5 goes there. Oh, and that is it. That's it. So we had to do this before the argument that I was looking for. So let's go back to this region. So if I try to have this join this part, then this region has no way of containing a 5. That's the argument I was going for. So this part is disjoint from this, so this we have to join this 8 here, and this will have to join the other part like this. So this region. And if we extend further, then it takes too many cells. We have 5 cells, 7 and at least an eighth one, and it will contain this one. But further, there would be 2 more cells, which is too many. So the region is like this. And now we can focus on Sudoku. And remember that this here had to be a 4-8 pair, so that is a 4. And there's an 8 somewhere inside this region, which can only be here. All right, so where do we look next? So we made some progress. So 5 and 1 must be somewhere inside this region. 1 must be there, 5 must be there. So where do we look from this point on? So something interesting here is that this here is 2 regions. So we have the digits from 1 to 9 2 times, and the same is true if you remove those 3 cells. I will color them. So let's use some coloring. This is 2 sets of digits from 1 to 9. If you remove these digits but add those ones, you also get 2 sets of digits from 1 to 9, which means that those green regions contain the same digits. And I'm not sure I can deduce a lot from this, but what I know is that, well, this part here didn't contain the digit 4 anyway, so 4 has to be somewhere in here, which is probably not that useful. And this digit here is somewhere inside here, so it's not a 7. But this is not saying much. Perhaps we should focus on digit 8, which is very constrained. Inside this region, 8 is nowhere here, so 8 must be in one of 2 places. So inside this region, 8 still has 3 places. And inside this region, 8 has 2 places. So that's probably not very useful. Except that it's really not useful. Oh, something that is useful is that this region here contains the 3, and it's not in those places, so it's in here. So that there is no 3 in here, there's no 3 in here, so there is a 3 here, so that this here becomes a 3-5 pair, and that's a 4 and that's a 1. That is useful, definitely. And now this digit here is the digit here, by the argument that I mentioned earlier, which is that this digit here is nowhere there. It's 1 time here, and it must appear twice in those bottom rows, so it must be here. And I will use some coloring to state that those are the same digits, which is probably not useful. I will pencil mark it nonetheless. Now, here we are left with 4, 6, 8, and 9. That's not a 6 because this isn't in the same region as that. This is not 4, not 6, so this is from 8, 9. And I will probably pencil mark all four options here. Oh, 6 is very constrained on this row. 6 is not in here through this region. It's not in here by the rules of Sudoku. So that is a 6, and this is a 3, which means that this is 5, this is 3, and this 5 is cloned into this cell. We get the 1, we get the 5, and I can remove the coloring. What am I doing? Now, those are not 1s. They must be from actually here. On this column, 6 can only be here. The remaining cells here are from 2, 7, and 9, and that here is not a 2. And those are from 7, 9, and 5. And that's not a 9. Here we must have a 1 and a 3 somewhere, and actually 3 can only go here, and 1 can only go here. And this can't be a 7, so that's a 9. And this here is a 7. This is going better than what I remember. This 4 is not here. And those are from 2, 6, and 8. There's a 6 here. This row still needs 1, 2, 7, 9. And I'm noticing that 1 is in none of those cells, so this region has the 1 in this place. So the 1s are in those cells. Here I need 2, 3, 7, 9. Let's just do some pencil marking. Still 4 options here. 2, 3, 7, 9. There has to be a 6 inside this region, and it can only go there. And looking, there are still a number of options for 6s. This region here still needs a 5, and it will be in one of those places, which means that this here is a 7. That's a 5. That's not a 7. One of those 2 cells is a 3, which means that this cannot contain a 3 because this cell sees this one through this region and this one through the column. That's not a 3, and that's not a 3, and that's not a 3. So 3 inside this region is here. That's a pretty difficult step. On this row, 7 is in one of 2 places, so that's not a 7, and actually that has to be a 3. That's the only place inside this region for the 3. That's the 3 inside this column. Now, a lot of cells with 2, 7, and 9 as candidates. We still need a 5 in this region. It can only go there. And this region already has a 5. Actually, we have all 5s in the grid. Well, now we do. That's not a 4, so 4 on this row goes there. That's not a 4. This is from 2, 7, 9. There again. There's a 1 in here, a 1 in there. Already mentioned. So this column still needs a 7. It will be there. No 7 here. This is from 2 and 9. This 9 is not here. Which means that inside this region, the 9 is either here or there, and that here can't be a 9, because it sees both cells. This is the same as that. I don't think it will be useful. So inside this column, we still need 1, 2, 7, 8. This is from 2, 8. This is from 1 to 8. There are probably shortcuts at this point, but I'm not seeing them. Oh, I'm seeing one of them. That's not a 7, so this is from, and that's not a 9, an 8, sorry. So 7 is here. Oh yes, this is from 2 and 9. I will pencil mark that, but this is now 7, which means that this is a 2, that's a 9. This is also a 9. And that here is a 2. This is 8. That's not 8. Two, 9, that's a 7. That's a 9. That's a 2, 8, 9, 6, 8. Here we need 4 and 9, so this is 4 here, 9 there. That's not a 4. That, oopsie. That's a 4. And this is actually a 6. That's a 2. This here is a 6. Those are 1 and 2. 7 is not here, actually. This 7 turns this into a 2. That's a 7. That's a 1. That's a 2. 9. Oops. 2. 9 and 7, and this finishes the sew. So we had to do some Sudoku to finish the building part, which is nice, I think. When you combine two kind of puzzles, it's good to have an interaction between the two types of puzzles. Well, that's a very hard puzzle in the end. And I would even argue that this was more difficult than the other Irregular, which was valued more than this one. I think that the expressionist sums was even harder. But there was really a high number of very, very difficult puzzles in this round. Very interesting puzzles, beautifully constructed, but that's, in my opinion, that's too much for Sudoku Grand Prix. Well, thanks for watching those videos. Thanks for sticking with the channel. See you soon on SudoKanard.